All right, we're doing day 8 of Advent of Code 2020, which has just started. Okay, so what's going on? There's an infinite loop in the boot code, and we need to implement this program. Okay, sure. Assemble single register, yeah. Mac equals 0 maybe. One, 6, 7, 5. Okay. Part 2. Jump. Not. Like that. One, 5, 3, 2. Okay, pretty good part 2. So what's going on here? I should probably clean this up because I don't know, we might use this again. We did in past years. Okay, so this is a sort of a assembler program, which are pretty common in Advent of Code. This is the first one this year. So we have this sort of virtual machine. It has 3 different instructions. It has ACK, jump, and nop. And it has a single register or piece of memory, right? It has a single accumulator, which just changes with the ACK instruction. And so, I don't know, you can write various loops and stuff here. I mean, this language is so simple that it's hard to do anything meaningful, but maybe it'll be extended. That's what happens in the past years is we started with a kind of simple language and then we started adding more instructions. Like a conditional jump would be very powerful. Okay, so anyway, for part 1, we just needed to implement this thing. And so you read each line, right? So you keep track of what instruction you're looking at, right? This is the line of code that you're going to execute. And then you grab what's on that line. Right, so there's 3 possible instructions. Look at the first word for that. If it's ACK, then alter the accumulator by the second word. I was worried that Python cannot parse integers with leading plus, but it can, so that's nice. And just go to the next instruction. If it's nop, you do nothing and go to the next instructions. And if it's jump, then you jump by that many lines, right? So jump plus 1 is the same as nop. It just goes to the next instruction. But like jump minus 20, takes you up 20. So anyway, you can keep going as long as you're at a valid index in the program. And that is good enough for part 1. In part 2, we said that we wanted to change one of the instructions. Right, so one of the instructions is bad. We should change a jump to a nop or a nop to a jump. Somehow we know that no ACK instructions are problematic, which is fine, I guess. And we know that we should get, it should terminate by going past the end of the program, right? But I guess probably the original input just gives an infinite loop. So what we're promised is that if we change exactly one line like this, it will go to the end of the program, and otherwise it will just loop forever. So we're supposed to, find that change and run the program. So I just tried them all. Right, so loop through all the possible lines. If it's a nop line, then try changing it to a jump. If it's a jump line, try changing it to a nop. If it's an ACK line, then you can't change it, so just skip this one. And then just try running the program, right? So one problem, if it's going to run forever, then, how can we run it? So I just said, okay, well, we'll just run it for 1,000 steps. Okay, and hopefully that's enough. Right, so keep track of the instruction pointer, right, what line we're on in the accumulator. And just run the program. And there's 2 ways to terminate, right? Either we could terminate by getting outside of this range, or we could terminate by hitting the bound on t. In theory, you could go really to anywhere outside this range, right? You could jump to like -1,000,000. But we were promised that it would terminate by trying to go one line past the end of the file. So that's what I'm checking for, right? If we're 1 line past the end of the file, then print the accumulator. And if we terminated in some other way, right, either we're at some other place outside the file, or we just ran for a long time, then print the accumulator. So it's possible that this would print nothing if 1,000 steps wasn't enough, in which case I would have just increased the bound on t. So that would have been fine. Okay, so let's clean this up to do part 1 and part 2. It's kind of annoying. I suppose we can write this function. This seems helpful. So the condition in part 1 was if we want to stop at the first instruction we run twice. So I'm keeping track of the set of instructions that we've seen. And we'll just keep running. Well, this hasn't happened. This should be old p, or maybe we should just call this p. Okay, so that should be part 1, and then part 2. This is super ugly. Can we clean this up any? Maybe it should be like this. Right, so just pre-split it. And then you at least don't have to reconstruct the whole line. This needs to be p mod. I don't know, this is still kind of gross, but also doesn't work apparently. Yes, well. Okay, so that gets 1675, which is right, and 7171, which is not right. Oh, I might be like keeping the changes. There we go. Yeah, that was a weird issue. The issue was that this is actually modifying, right? Even though I was sort of making a copy, this was actually modifying like this inner list, which was being shared across all the copies. So it was not like reverting the change after each line, basically. Anyway, deep copy handles that. Okay, so now we have a program that prints out the answer to part 1 and part 2, which is what I wanted. Yeah, I think this is kind of reasonable. I don't know. It's kind of, you sort of would want like a function to run the program, but then the condition to stop in part 1 is very strange, right? You need to like keep track of which instructions you've seen. So I think this is reasonable. Yeah, so this is the heart of the virtual machine, right? We have some program we want to run, we have some line that we're on, and some the value of the register. So, you know, we parse the line, figure out what command to run, modify the register, modify the instruction pointer, the next line to run, and then return the new instruction pointer and the new accumulator, right? So to run it, you just do a loop like this, or like this, I guess. So yeah, that's it for day 8. Kind of a cool little metaprogramming challenge, right? We're implementing a little language. So that's it.